All right.
Oh,
Why don't you kick us
excellent.
off?
Sounds good. Everybody, welcome. Thanks for joining Beers with Engineers sessions 20, right? It's amazing to think we've had 20 of these sessions now. Really excited to be here with you all today. Will and I always joke that this is our favorite work day of the month. So appreciate you jumping on and joining with us today. We'll just kind of review how we always approach things. First and foremost, there's always the safe harbor notice. Things that we'll be talking about today may or may not be released yet. They may or may not come to fruition exactly as we have talked about here today from a feature standpoint. So don't make any purchasing decisions based on these conversations today. And we just want to make sure that everybody's clear and covered. So as you guys know, we keep things pretty light here. So agenda is fairly straightforward. We'll talk about why we're here, who we are, kind of run through the tech deep dive, and then open it up as always for Q&A afterwards. So why did Will and I start this, right? The whole goal of this was to connect with people in the ServiceNow community who are also on the cloud native journey and bring folks together and talk about relevant technical topics that are important to that group of folks and to build a community about it. So it's really important that we build this community and talk through all these components, and we're just so blessed that we have so many great people who join us every month. So who we are, I'm Mike Gallagher. I am the manager of the enterprise applications team here at DRW. I have been doing technology for multiple decades. I love, in particular, IT operations management. That's been a long focus of mine. I am a Kubernetes nerd and run most of my home lab stuff on Kubernetes. And I one of my great philosophies is that we need to solve business problems effectively, efficiently, and intelligently with technology. So, and today I am not drinking a beer because I'm feeling a bit under the weather. So I'm going to have a Liquid Death mango chainsaw. So, Will, over to you.
Nice. Like the name.
Yeah.
Hey, everybody. Will Hallam, ITOM architect over here at ServiceNow. Been working in technology for several decades. Right now, focusing on IT operations management, particularly about automating tasks, which tend to be mundane or repetitive within the IT operations management space, with a particular focus on cloud native, public cloud, a lot of Kubernetes work. Really enjoy being able to make those things painless, seamless, and automated. And today I will be enjoying from a local brewery in my area, a Lake George's IPA from Adirondack Brewery.
Sounds good.
Yes. Okay. So today we're going to dive into something that came out earlier in November called the it's under the ACC visibility plugin, and it's called Cloud Native Operations for Visibility, and it features a functionality called the Kubernetes Informer. So it was released November 2nd as part of ACCV 3.4.0. And so some highlights of what this provides. The first thing it provides is a turnkey installation. We now have a public container image that delivers this functionality. So for those of you who are familiar with previous iterations of cloud native ops, you probably recall that after releasing that for having that be out for a couple of months, we kind of pivoted from providing public images for those Kubernetes or containerized workloads towards just providing a recipe. And so, and that was due to some inherent vulnerabilities on the underlying distribution that those images were based, and just an overall very high level of sensitivity to vulnerabilities that get flagged in container images. And so that introduced some additional rigor on the customer side that was not in all cases well received. And so in an effort to make the customer effort less when it comes to deploying ServiceNow functionality in their container ecosystems, we now have the Informer with a publicly available image. It can be, there are instructions in the documentation, so it can be pulled in and hosted in an internal repo, as many customers are apt to do. I think, Mike, that's kind of your standard practice at DRW. Is you don't get stuff from public repos, you put it all through your own internal repo, even if it's just caching those publicly available images.
Correct.
In terms of deploying those to your cluster, we provide Helm chart and YAML manifests off the shelf that you can just use to deploy or customize and then deploy into your Kubernetes clusters. And so what does this capability do? It provides quick CMDB updates, pretty much the fastest, most responsive updates to your CMDB based on changes within your cluster that you can obtain.
Yeah.
And that's because it's extremely lightweight. It's constantly running and interrogating what's going on in your cluster. And when it detects changes, it sends those in directly to your ServiceNow instance. This does not require, cannot use a mid server. It communicates directly with the ServiceNow platform that it's configured to pair up with, sends those events in via a dedicated event queue. Those events are handled via dedicated event processors within your instance, and they update the CMDB in near real time, anywhere from on a moderately sized cluster, it's a matter of minutes. And we'll talk about talk a little bit about scaling in a little bit. But the responsiveness is the best of any of the options that ServiceNow provides for discovering Kubernetes. So I touched a little bit on the resources within the instance side, and that's pictured here on the right side of this diagram, which kind of shows how the Informer is set up. So on the left side, you see your representation of how it looks in your Kubernetes cluster. And the Informer itself continually polls for events, change events within your cluster, pods created, destroyed, various workloads, stateful sets, daemon sets created, destroyed. Does that by querying the Kubernetes APIs directly. Then when it detects changes, it prepares those changes into a payload, and it puts them in a queue, and then periodically uploads the payloads from that queue to the ECC queue on your ServiceNow instance. From there, the events do reside in a dedicated event queue channel within the ECC queue, and they are pulled by a dedicated event processor. And then there's a couple different gates that are in place to prevent a highly active Kubernetes cluster from flooding your instance with traffic and impacting the performance of other instance functions. One of those things is we limit the rate of the data sent into the instance to no greater than a megabyte every 30 seconds. And there's an internal queue on the Informer side that will hold up to 100 megs of payloads and just kind of release those in 1 megabyte chunks as applicable. The Informer has built-in back-off. So if your instance is being patched or is otherwise non-responsive, the instance isn't going to keep hammering your network trying to retransmit. It has a progressive back-off where it just keeps increasing the wait time before the next attempt to connect. And then once the payloads get to your instance, they do go to a dedicated event queue, and the event processing is limited to occupy a maximum of 2 concurrent threads on your worker nodes that are executing, all the code that executes on your instance. So this processing can't grow without bound to the point that it affects resources available to other instance functions.
So, and what's interesting about that is those, 1 meg and 100 meg limits seem kind of small. But when you stop and think about the fact that most of these updates are going to be in the kilobytes size, right? That would be a significant amount of changes on a cluster in a very rapid time frame to be able to like kind of flood those buffers. So it's a pretty reasonable buffer size, and A, shouldn't really impact the performance of your cluster, which they did some testing on, and B, should hold quite a few updates before it overruns those buffers and starts, tossing stuff on the floor.
Yeah, absolutely. And I was curious, so I was able to track down internally within ServiceNow bubble. I was able to get a look at the source code, the Go source code for this for the Informer. And one of the things that I noticed is that, and I think it's mentioned in the documentation, but just more of like a side note, so I didn't really notice until I was looking at the code and some of the comments. It actually has built-in kind of a built-in squelch function, where if a given event is happening more than 15 times a second, then it will by default kind of suppress that event. Because there are some things that happen within a cluster that are just so rapid, it doesn't make any sense to try and capture those. So when it's happening multiple times a second, there's actually code in there, which I thought was pretty clever, that they're automatically kind of squelching that kind of stuff and focusing on the things that are more, along the lines of like something that lives for minutes or hours, as opposed to something that lives for fractions of a second.
Yeah, that makes sense.
Yeah, it's pretty sweet. So a question that we've been getting for the last year and a half, 2 years, and is not going away anytime soon, because we've got all these different options for discovering Kubernetes, is, when do I use which option? What's the best practice? Which one is the best? And so, as with many things on the ServiceNow platform, the general answer is it depends. And so what I try to do here is capture some of the things that determine whether Kubernetes Informer might be the an attractive option for a given customer, in contrast with some of the other mechanisms that are available.
Yeah.
So the first thing is, I mentioned this is released as a publicly available image. You can grab this image off Docker Hub, cache it internally. If you want, you can pull it direct. There's it's hosted on Docker Hub like any of the other publicly available images. It's very lightweight and it scans with 0 vulnerabilities. And so if you appreciated some of the benefits of the original release of Cloud Native Ops, but didn't like the rigor of having to manage the generate images, or the fact that the images were fairly large, they are based, both the agent and the mid server images that came with that first iteration are based on full distributions, full OS distributions. So they tend to be kind of large. And that was also what led to them having a bunch of vulnerability hits, is because there's loads of packages in there. This is very bare bones. It's basically, there's a basic Golang build container that's used to compile it. And then there's literally like this very basic shell of a container image that's used to copy in the executable, have a couple file systems, and pretty much that's it. So if that is appealing, then Kubernetes Informer may be right for you. There's no discovery schedules whatsoever required. Even the original CNO 1.0 or first iteration of CNO did create a cluster-wide schedule to run by default once a day when you deployed Cloud Native Ops into your cluster. If you'd rather have 0 discovery schedules and just have your clusters discover themselves and send the data into your instance, then Kubernetes Informer may be for you. If you'd rather not manage cluster credentials, the Informer may be for you, similar to the first iteration of Cloud Native Ops. There's no cluster credentials required. All the permissions are provisioned via the Helm chart or the manifest. They create a service account. The permissions that service account are given is completely transparent. So they are pretty minimal as far as providing just what's needed to begin with. But if you did want to tweak something here or there, in fact, I think somebody had asked a question, can we control what is discovered? Today, that would be one method, is if you tweak the service account so that it can't interrogate Kubernetes resources that you're not interested in, then those resources wouldn't get pulled into the CMDB. Number 4, if you want fast turnaround, like I said, this is the fastest way to get your CMDB updated to contain Kubernetes information. And we did do some performance testing and published that in a support knowledge base article, where we share kind of small, medium, large t-shirt size clusters and change rates and the commensurate speed of updating the CMDB that comes with each of those. So it's fairly well understood, at least within different spots in the spectrum, what your expectations should be. So you can review that and see whether that meets your needs in terms of how quickly would we like our CMDB to reflect what's going on in our cluster. Number 5 is kind of a caveat, which is the Kubernetes Informer, the discovery that it performs, is independent of our discovery patterns, which are used by our agentless, serverless discovery, as well as the original iteration of Cloud Native Ops. So if you had started your Kubernetes discovery journey using patterns, and then you had customized those patterns, perhaps to add some additional attributes, pulling in from the metadata to discover some additional resource that was not discovered out of the box, or if you're leveraging one of the extensions that comes out of the box with the Kubernetes pattern, then you would have to address how losing those additional bits would impact your Kubernetes discovery, and then decide whether the juice is worth the squeeze for getting that low administrative overhead and the very fast update speed against those customizations that you'd performed within Kubernetes patterns.
Another point there is metrics ingestion, right? For health, right? This is just purely visibility. It doesn't ingest any metrics. Also, just a quick point, I went and looked at the container image on Docker Hub, and the Informer is 22 megs, right? Which I think the old mid server that shipped with the CNO was like gigs.
Yeah.
So yeah, this is a massive like thin down of the infrastructure components of it, and it's also going to be faster to deploy, easier to manage. So it's just in general, if it fits for your use case, it's a great option.
100%. And yeah, that's a great call out. So even though this is under the Cloud Native Ops for Visibility banner or kind of product family, it does live alongside the previous Cloud Native Ops plugin. So Cloud Native Ops, when it first came out, was its own plugin. The Kubernetes Informer functionality is rolled into the ACC Visibility plugin. So you can run both. If you've deployed CNO already and you're using some of those metrics and monitoring capabilities that also come with that iteration of Cloud Native Ops, you can run them both, use the Informer for discovery, and still, if you're running some of the standard monitoring checks or what have you with the original one, they can live together side by side. That's not an issue. So a few caveats, both Mike and I have played around with this some in our various test environments. And so just wanted to capture some of the things that like questions that arose that we got answered kind of up front. So you don't have to reinvent the wheel. And then just kind of things to watch out for. The first thing is basic auth. Right now, the only way for the Informer to authenticate into your instance is via basic auth. And when I walk through the demo, I'll show you how that gets set up. It's basically you create a username password record in the form of a Kubernetes secret with a specific naming convention. And then the Informer pulls those credentials and uses those to connect to your instance and populate the ECC queue.
Yep.
There's roadmap items to add things like mutual authentication down the road, but right now it's basic auth only. I already called out the fact it's self-contained. It doesn't use patterns or any pattern extensions. So if you're leveraging customization on the Kubernetes pattern or one or more of the extensions that come with the pattern and discover extra things like the YAML files or some of the specific OpenShift stuff, then that you can't just kind of port that over to the Informer. When I was looking at the Informer source code, I did notice that it does have code to handle OpenShift. So you should see successful discovery within OpenShift environments. It's just that OpenShift specific extension that's part of the pattern is not ingested or used by the Informer. The Informer is a completely separate standalone code base today.
Yep.
Already mentioned it doesn't use the mid. There's no option to use the mid today. So it does need to have communication with your ServiceNow instance. It does support setting up a proxy. So it doesn't have to be direct egress, but it does need a path by which it can communicate with your ServiceNow instance. And already called out, it coexists with the prior CNO plugin. So you can, in theory, run both. Although after you go through and install Informer, unless you really hung up on some of that functionality, like the monitoring stuff that came with the earlier cloud native ops, I can see you just like totally throwing the original one in the dumpster because it's just so much easier to deploy and manage than
and maybe log ingestion, right? I think log ingestion was there in the old CNO, but not here. But either way, if you're just looking for what's running on my clusters and I need to know fast, this is definitely the way to go.
100%. And speaking of log ingestion, we now have a pretty cool story to tell, which we're going to talk about next month, about ingesting cluster logs, pod logs natively using OpenTelemetry and sending that log data directly into our cloud observability solution. So stay tuned for that. That's a fairly new offering. It's pretty cool. We're gonna have some fun with that in December. Okay, so now I'm gonna tempt the gods of live demos and actually just walk through the process of deploying Kubernetes Informer and just show, hopefully, how quick and easy it is. So first of all, I'll just jump into my demo instance. And this is a out-of-the-box Kubernetes dashboard that comes when you install the Kubernetes patterns. And you can see I've got 0 Kubernetes resources visible to this cluster. To this instance right now. No clusters and namespace, nodes, etc. 0 Kubernetes visibility. So what I'll do is I'll just start with the first section in our standard documentation on CNO for visibility deployment and just walk through the steps. So I've already ahead of time ensured I've got my prerequisite plugins applied. I've got my system with kubectl on it and Helm and all that good stuff. And I've also created my user on my ServiceNow instance and given it the discovery admin role. So I'm kind of picking up here on step 2. The first, it's kind of the first interaction with the Kubernetes cluster that's required. And essentially, it's just to create a namespace in my cluster for the Informer to live in. So I will go ahead and do that. Actually, I'll just do copy pasta just to. Okay, so I've got my namespace. And then the second thing is once we've got our namespace, we create that secret that I mentioned. So we store the credentials required for the Informer to place those payloads in the UCC queue as a standard Kubernetes secret. So I will paste that line in and kind of fill in the blanks here. And I've kind of stored my credentials in some files so I don't have to try and obfuscate them after the fact for YouTube. Double check my instance name. CNO v demo. Okay, now I've got my secret created. So that's all I need to do because I am going to go ahead and just use the publicly available images. If you're pulling the image, as is common with customers, there's instructions for how to do that in step 4. And then step 5, if you are going to route your outbound traffic through a proxy, there's just kind of an admonishment to make sure you've got the proxy host name and port identified before you attempt to deploy the Helm chart or the manifest. So that's my prereqs. Now just go to the second section in the docs, which talks about deploying the Kubernetes Informer into your cluster. So I'm going to use Helm, and we maintain the kind of the lookup, which includes the latest Helm and raw manifest download links in this support knowledge base article. All these things I'm linking to, all these docs, will be included on the links page in the PowerPoint deck that we send out as a follow-up from this session. So you don't have to kind of take screenshots or anything like that. It's also very nicely linked in the docs directly, so you can kind of just click through as you're going through the docs for additional supporting documentation. So grab this Helm install command, paste that here, and then start filling things in. So the first thing, working backwards, is the Helm URL. So I'll grab that Helm chart URL from here. And then I'll just kind of keep going backwards. I'm not using a proxy, so I'll just clear that out. And I'm not using private repo, so I'll clear that out. So the cluster name parameter is used for a couple things. One is if you've got clusters already in your CMDB, then you want to make sure the cluster name that you're assigning matches so that it doesn't inadvertently create a duplicate CI. The other thing is it just allows you to apply a recognizable name to the cluster, because otherwise what it'll do is the default name is something like Kate's cluster and then the big long Kubernetes UUID, which is a little difficult to recognize visually. So this just gives you the ability to apply kind of a cluster nickname, or if there's a naming convention that you apply. So in my case, I'm just gonna apply a fairly simple name to the cluster. And then instance name, which I'll double check again. CNO v demo. Yep. And then my namespace name. Okay. And we'll fire that down the pipe. Fingers crossed. I've been really impressed with the quality of these docs that they put together for this, especially given that it's essentially a 1.0 for the Kubernetes Informer. There's a lot of helpful links like these in here that talk about how you can configure the memory limitation. The larger your cluster is, the larger the memory is going to need to be for the Informer. And the performance testing knowledge base article, which is also linked in the links page, talks about the guidelines. There's a calculation where you're based on the number of pods, you apply a corresponding memory limit, memory request to the Informer pod. And then some helpful links on changing the discovery. So by default, a full discovery gets run within the cluster by the Informer once a day. And you can change that frequency to suit your operational needs. It's really just kind of a catch-all that if something happens, like if the pod dies and a bunch of other changes occur, you want to rerun that baseline periodically just to kind of level set for any deltas that might have been missed. Excuse me. And then we also provide the ability to kind of go completely the other way and just do a periodic full cluster discovery and disable the continuous discovery functionality if that's something that you would like to do. Okay, let's see how my Helm chart ended up. Looks successful. So we'll take a look at the pods on my cluster. We should have an Informer pod, which we do, this guy right here. And so now if we want to see how it's doing, we can pull the logs. It's interesting. Trying to use autocomplete and it's not happy for some reason.
Because there's no get, it's just logs.
Thank you. Yeah. Okay,
By the way,
so
if you haven't played with it, I recommend Stern for looking at logs from Kubernetes pods. You just you say Stern and then a namespace and then kind of a pod name, like a fuzzy name, and it'll stream all of the logs for all of the pods that sort of match that name to you.
yeah, that sounds awesome.
Yeah, it's
So
really nice.
best things about Kubernetes is like you you think, man, I wish there was a tool that would let me do this with Kubernetes, and chances are there is at least like
Yeah.
3 of them. It's
Yeah.
a great ecosystem to work in.
Love it.
All right, so this all looks happy. We can kind of see initial discovery completed, sent ECC message. So now if I go back to my Kubernetes dashboard and do a little reload here. Bam. Look at all this Kubernetes goodness that just came in within the span of minutes.
Yep.
And as far as, Kubernetes discovery, this is fairly unparalleled. And granted, I'm on a smaller cluster, but until you get really large scale, based on that knowledge base article that documented the performance testing that was performed, you get updates in your CMDB within minutes of the change occurring on your cluster, it's just awesome. So that's our baseline. And so now just to kind of do a quick demonstration of how quickly changes are recognized and updated within the CMDB, I'll just go to my pods listing. And I'll pick a pod to get rid of and monitor to see how quickly it takes for it to be replaced. So I'm going to go for the metrics server pod. All right. So right now it says I've got a metric server pod running. The identifier ends in ZDSP. I can kind of confirm that here. So here's my metric server pod ending in ZDSP. So I'm going to go ahead and kill that. Not kill. I don't know what I've got. Got subcommand
Too many of them.
illiteracy at the moment, but okay. So now I've gone ahead and deleted that pod. So now if I repeat my get pod command, I should see a new metric server pod running. And I do. So I've got metric server pod identifier ends in JV69. And so within my test environment, generally, okay, so got the new one has already shown up. And actually, the behavior right now, the way the Informer updates things is, I'm just going to add install status to my listing, because I believe the way it behaves. Okay, so yeah. So it's already basically updated that pod, and under the covers, what it does is it creates or it updates the record of the pod that was deleted, sets the install status to absent, and then there's an hourly cleanup job that runs against the Kubernetes tables and deletes any of the resources that are marked absent. And so we can kind of see, because by default, when you're viewing Kubernetes tables, it's automatically going to filter out anything that is has an install status of absent. And so now, just a few scant couple of minutes since I performed the action, we can see that the CMDB is again up to date, reflecting reality on the cluster. So in terms of, so I mentioned there's a scalability doc out here on support, and that does a good job of setting expectations as far as if your cluster size falls within this range, here's the update speed you should expect to see. And I kind of, I was very happy to see that, because sometimes we can see that kind of performance expectation be more of an afterthought, and we're left to kind of figure that out in the field. So it's nice to have a heads up on what to expect there. So running through a few questions that we have in the Q&A. One of the questions is any opportunity to explore service mapping use case with the new iteration of CNO. And so my understanding, based on just a quick overview of the roadmap and the directional strategy for CNO in general, is that it's going to converge more closely with the ACC visibility offering. And as part of that, I expect it is going to get more rich connectivity data coming in from the cluster over time, which will facilitate those service maps. There's an effort right now to support service mapping via the agent client collector. And so as the Informer intersects and converges with ACC, I think we are going to see improved breadth of data that's available from a Kubernetes cluster. For those who are familiar, if you're running Kubernetes and you want to do service mapping, your options today are either tag-based or the Open Telemetry Service Graph connector. And the the OTel Service Graph connector, it needs instrumentation in order to do kind of a rich service map. So there is that a bit of a heavier requirement to make sure your cluster is configured in a certain way in order to get those rich service maps. And so it does seem like directionally, by adding the Informer, and eventually, the overall vision is for the need for a separate Informer to eventually go away in favor of a more general purpose ACC based capability. But in the interest of providing something that just gives you this massively quick update, with a lightweight footprint, the Informer is kind of our first iteration on that overall strategy.
And to be clear, right, like this, it does ingest the Kubernetes labels so that it can do tag-based service maps like today, right now. So if you're already doing tag-based service maps, it'll ingest that data and update the maps automatically based on that data. So it's, you can kind of crawl before you walk, run, and fly.
Yep. Yeah, you have the same capability for generating service maps with this as you would with serverless discovery or using the original iteration of CNO. And that was actually another one of our Q&A questions was, will it gather tags? Yes. This is going to gather all your Kubernetes labels. If I pick a pod, should be able to see, yeah, here's our key values right here, which are the Kubernetes labels that are getting pulled in. One comment from one of my ServiceNow teammates was that he actually worked directly with a customer whose specific needs directly impacted the creation of this, and they had a need for discovery and updates at a large scale. And so that just kind of reinforces the fact that there was a lot of thought that went into being able to support those large scale installations where there's clusters with thousands of pods running, and being able to keep CMDB in step with what was going on inside those very elastic environments. And let's see, the last Q&A question had to do with service mapping. I think we kind of really already dug into that. Essentially, it's tag based today. And the directional strategy is to ingest additional metadata to ultimately gather more insight into what's going on between individual workloads. The challenge we've had so far is it's kind of that double-edged sword of Kubernetes, in that Kubernetes is so modular. You can have 10 different customers and they're each handling their Kubernetes network traffic using a different plugin. So it's a bit challenging to come up with a one size fits all or a universal solution, but we're getting there slowly but surely.
Yeah, and that's really where the OTel piece can come in and help out with that, right? If you're instrumenting at the code level, then it doesn't really matter what network provider plugin you're using in your cluster. We can see all that data with OTel, so that'll kind of help smooth some of that out.
Absolutely. Okay, well, that's my soup to nuts demo. I'm thankful that even though I was doing it live, kind of without a net, that it all worked really well. Really been impressed with this Informer. Just overall, not hit any major hiccups or anything so far.
Yeah,
so
agreed.
That's really pretty awesome.
Yeah, the install was like butter, right? Like it's exactly what you expect from Kubernetes platform, being able to deploy it quickly and easily with a Helm chart, utilizing secrets, quite helpful. I haven't tested putting it into a GitOps style environment yet, but given the fact that it's a Helm chart, I would not expect it to be terribly difficult. So
I mentioned we'll have some handy links in the slide deck that we'll send out to everybody who signed up for today's session. It's another aspect of this rollout that's been really positive for me, is lots of documentation augmented by lots of knowledge base articles. And so I already mentioned our next session, we're planning for December 14th to talk about the new capability within our cloud observability product suite to take logs. And it's not just Kubernetes logs. We'll probably kind of have that focus, since that's our overall vibe here at Beers with Engineers. But yeah, it's and one of the sessions Mike and I went to when we were at KubeCon this month, they were talking about the fact that they've actually officially recognized and support pulling log traffic in through the OpenTelemetry collector. And I guess it's been there for a while, but now it's finally like full GA 1.0, completely blessed by the OpenTelemetry collector project. What that means is you basically just, if you've got OpenTelemetry collector running, which is available via Helm chart, you just uncomment or you enable the log collection stanza in the parameters, and then it's going to start pulling in logs. And there's some additional, there's some additional settings required for pod logs, because depending on your container runtime, those pod logs are going to reside at a different path on your cluster nodes. But other than that, that's kind of all you need to do. And so hopefully we'll be able to kind of share some of that behind the scenes, under the covers stuff with you guys next month.
Looking forward to it. As always, thanks everyone for joining us. And look forward to seeing you guys next week.
Next month.
Yeah, next month. I wish it was next week. Next month.
Yeah, me too. Thanks, everybody.
Take care.